and today we are going to be making merge sorts. So merge sort is a divide and conquer sorting algorithm that recursively calls two halves of an array, sorts them and binds them back together so you can, or rather merges them back together. So it's very fast, uses a big O n log n time complexity, and it's really good. You will really like it. The simpler ones that are easier to memorize, like insertion and bubble sort. As you can see, I made some of those, and I have like a merge sort. Oh, this is the merge sort file, yeah. So so that's what we're going to be doing today. So I will be walking you through this. Please like and subscribe. This is my first video. Let me know in the comments if I do anything that you think I should do better or any way I can improve, but please just let me know. I appreciate you guys' support and thanks for coming out here. So we're going to write merge sort as a function, which is, I think that's how everybody else writes it. So we'll start by defining merge sort. Now this function is going to have one argument, which is our array. So in this array, the first thing we are going to do is to check the length of our array to see if it is greater than or less, like if the number of elements in the array is less than or equal to 1, then we just return the array. So we can do this. There are two ways you can do this. You can validate this at the beginning, or write the function everything for the case if it is greater than that in one thing, and at the end you put an else statement to just return it. It's completely up to you. I think I prefer to write everything in the if statement and then at the end just put an else statement to return it. It's personal preference, really isn't anything. You can do it with whichever way you like. So I can say if the length of the array is greater than 1, so we want to split the array in half. So we need to find the midpoints to split it in half. So we're going to make a variable called midpoint. Spelling this off. So midpoint, we're going to basically divide the length of the array by 2. So now that we've done that, we have divided the length of the array by 2. We are now going to, so by dividing it into 2, this is going to be what will make up our left and our right side. So we can say left half, our left and right half, will be an array that begins at the middle. Like it's going to be an array that begins at the middle. That begins at the very beginning of the array till the middle of the array. So we can just do this and then say till midpoint. So what this does is basically sets everything from makes an array, like makes the left half array, which is everything, all the values starting from the very beginning to the midpoint. That's the left half, and then the right half is, you guessed it, everything from the midpoint till the end. So till the end. So now that we have these two down, we want to keep dividing and sorting this, but the sorting function will come after this. We want to keep calling this recursively to keep dividing it into different halves. So we are going to call it into merge sort again. This is the recursive call. We're going to do that for the left half, and we are going to do that for the right half. Okay. Oops. Oh, I guess I spelled this differently. I like to spell it like that. That seems right. All right. So we have successfully divided our array into half, and This is going to keep calling it back to keep cutting it in half, in half, in half, in half, in half. So the left half will be cut in half once more, and it will keep going, it will keep going, and it will keep going. So I don't know if I should test this now. I probably should. So what I'm going to do right now is I'm writing this merge in advance, and I'm passing in the left half, the right half, and the array. So basically what this is I'm really writing this in, I'm really writing this in advance. I am going to now write a function called merge, which is really going to be this main sorter. This is what's going to sort and merge each and every single one of the halves each time it is split in half, sorted, and it will just keep merging them back. So this is let me say the beginning brains of it, but this is like I think I usually view this next merge function I'm going to write as the main brains behind the merge sort algorithm. So let me just write that else statement. So we're going to say if there's a white space. So we're going to, since like if the length of the array is not greater than 1, we just want to return that array. Like we just want to give them back the array. Like we're not doing anything with that. So let's come down here and define merge. So we're going to give it, let me call this left. Let's just call it to make it easier to type. Right, and we can call it array, but I want to call it list int, like a list of integers, just to make it different. So here we're going to create what some people call what I would like to call pointers, but mainly I'm just going to make this very simple. We're going to use them to index throughout our while loop. So let's do this. So this is what we're going to use this for the left, or let me make it more specific. I'll call this left pointer, call this right pointer, and I'm initializing them as 0, and I will call this the list pointer. Put that as 0. So just an extra space. So now we are going to start. So we want to make sure that we haven't gone through everything in our arrays. So we will tell it that, because we want to make sure like we haven't gone through, like we haven't gotten to a point where we are supposed to have like gone through all the elements of our array. So this while loop I'm going to make is going to make sure that that doesn't happen. So this will continue to occur while we are within the number of elements of the array. So while this is less than the length of left, and the right pointer is less than the length of right, we want to check if, so now this is where, I probably misspelled something. I must have spelled something. Okay. All right. There we go. Now this is where you decide whether you want to make it in ascending or descending order. So whichever, all that really changes here is like a greater than or a less than sign. It's not really anything too flashy, too fabulous, but I'm just going to say maybe we should, for this tutorial, I will make it in ascending order. So we're going to say if what is in the left the number in the left is less than the number in the right half. Just to be clear, this left, right, and this is the left half, the right half, and this is the actual array itself. I'm gonna put a little if statement here. Jump into the next line. So if this is there, we want to put this list pointer. Whoop, didn't spell that well. We want that to be equal to whatever is in the left pointer. So basically what I did right here is I said if the number in the left half at, let me say, the index 0 is less than the number in the right half at the index 0, then put it into the array. Like I rearrange the array for that to be the first thing, and then so on and so on. And this will continue to give priority like to this lesser numbers in. So it's basically checking, comparing the left half against the right half and checking which is less than or which is greater than. And whenever the number in the left half is less than the number in the right half, it will put that into the array, like rearrange it into the array. So that's how we get, through that we'll get our ascending order. So that done, we'll just need to increment our left pointer. So we could just do this, but I've had so many horrible experiences with this. So yeah. Then the else statement, we will, if it's not, then we just tell it to put yep. See, like, this is why I probably should have used I's and J's, but it doesn't really matter. Okay. Okay, so that is good. We will we'll increment our right pointer just quickly before anybody can see. All right, and then at the end of this, you will want to increment your list pointer at the end of this whole debacle, so that way it will help you iterate through everything and like really put in everything. Okay, now for our final case within this, we want, when we get to the point where if there's like anything, if we've gone through everything and we're like, okay, with this, maybe we had an odd numbered list and we've gone through everything, we sorted everything, and we have like one thing left in the left half and nothing left in the right half. We'll just check that, compare it accordingly, and append it to our list that we have made, our sorted array. So I will say while the left pointer is less than the length of our left half, that's like there is still something in there. Like, why is there something in there? We want to put that into our array. Oh gosh. Oh, sorry. Okay, so we're going to increment this just very, very quickly. left pointer, okay, oh, put an E right there, and the list, whoops, I want to increment the list pointer. So I know I could have used the plus equal to 1, but you know what, I feel like typing a lot today, you know, just like some days it be that way, you know, but yeah. So let's do the same thing for the right half. So we will say while the right pointer is less than like there's still something in there, we want the list int. So this will append it to our sorted array accordingly. And after this, we will do a quick test. Well, time to increment. You know what? Yeah, I guys, I'm sorry, I gave up on that. So much typing. It's not for me. Okay, so that should be the end of our program. So now, I hope you guys all understand that this is the part that really does the recursive work, constantly dividing it, and every time it divides it, it calls this to it calls up the merge function by passing the left half, the right half, and the array itself as arguments to the function, and then this iterates over it by comparing it and sorting it accordingly. This area is the main sorting region. By this is where it sorts by an ascending order by putting the smaller one, by switching the smaller one with the larger one towards the end of the array, towards the beginning of the array rather. So that way you get things going in ascending order from 0, 1, 2, 3 and stuff like that. Then these are all precautions to check when that, okay, we have done all the sorting. Is there anything left in this? If there's anything left in this, let's just append it accordingly to the array. So now let us make our test case. We will call this little friend n. The name of this thing is n. I will put all our favorite numbers in it. 1, 2, 3, 4, 44. Well, that's a big number. Put a smaller one. Put 0. Put some of that. Some of this. -2 something million. Let's put everything here, guys. Oh, okay, that was embarrassing. All right. Okay, Python, looks like Python really is angry with me. My editor is like, you are not spacing properly. But I'm like, I space properly all the time. So we can have multiple test cases. Let me tell this to print. So let's say this is n. And then I want it to merge sort n. Oops. That did not go as planned. So I wanted to merge sort n, and then I wanted to print n. Yeah, I know you expected 2 blank lines, but we don't always get what we expect, do we? So now let's run it. And you can see it sorted it in ascending order. This is the lowest number, this is the next lowest, and like that till we got to the highest number. So yes, the function does work. It is very fast. It sorts things really quickly. And okay, so let us also try some of the fail safes. For example, getting when we pass an array that is less than 1. So let's make this an empty array. All right, this is empty. We should get the same empty array back, which we just did. Let's say we pass something with only one number. We're getting one number back. There is no sorting done in this. So, however, if we decide to put multiple numbers, this is just like a second test. And yes, everyone in the comment section, I am mashing my keyboard with different numbers, and it's really fun. So let's check it, and yep, sorts it perfectly and accordingly. Now let me show you guys what I mean by just a little bit of switching. Like, this is the main sorting region. Just a little bit of switching, we will be able to make it tell you whether this is in descending order. If you want to make it ascending order, we now said if what is in the left half is greater than what's in the right half, then we want it in our array. So let's test it now. So you see, it just reversed it. It put the biggest thing and it keeps going lower and lower and lower till it gets to the lowest. So I hope everyone enjoyed this video. I hope you learned something new. I will leave my code in I'll leave the code in the description for you guys to use in case you need for referencing. And like, you can always pause the video and learn more and take your time to learn more about it. Sorry that I'm stuttering a lot. I'm a bit nervous. This is my first YouTube video. But let me know in the comments what you guys would like to see, other things you'd like to see. If this was helpful, if this wasn't helpful, please, I enjoy your positive feedback. Let me know what I can do to improve. If I said something that wasn't on point, I would appreciate, because I'm learning too. So thank you guys. Please subscribe, give this video a thumbs up, and welcome to Lightning Code.